While both extremely low frequency and very low frequency systems are designed to overcome the barrier that seawater presents to standard radio waves, they operate on different scales and serve completely different tactical purposes for submarine fleets. Here is how VLF, operating between 3 kHz and 30 kHz, compares to ELF, operating between 30 Hz and 300 Hz. Frequency range: ELF 30 to 300 Hz, VLF 3000 to 30,000 Hz. Depth penetration: deep, hundreds of meters for ELF, while it is very shallow, 10 to 40 meters for VLF. Data rate: around 1 character per minute for ELF, while it is 50 to 300 bits per second for VLF. Submarine posture: deeply submerged, full stealth for ELF, while for VLF it is near surface or trailing an antenna buoy. Primary use: global bell ringer or paging system for ELF. Primary text-based command broadcast for VLF. Depth penetration. The physical rule of radio waves in seawater is simple. The lower the frequency, the deeper the penetration. ELF. Because of its massive wavelengths, ELF can penetrate hundreds of meters into the ocean. This allows a submarine to remain deep, fast and completely stealthy while still receiving the signal. VLF waves attenuate or weaken much faster in conductive seawater. They typically only penetrate the top 10 to 40 meters of the ocean. To receive a VLF signal, a submarine must either ascend to periscope depth or release a long buoyant wire antenna that trails just below the ocean surface while the submarine stays slightly deeper. Data rate. Bandwidth is directly tied to the frequency of the carrier wave. Lower frequencies means less space to encode data. For ELF, the data rate is agonizingly slow, often taking several minutes to transmit just 3 or 4 letters. It is completely incapable of carrying voice, complex data, or real-time tactical updates. VLF, while still incredibly slow compared to modern internet or standard military frequencies, VLF has enough bandwidth to transmit continuous text-based messages like teletype. It can transmit at roughly 50 to 300 baud, allowing command centers to send detailed operational orders, weather updates, and strategic commands in a reasonable time frame. Practical use. Because of their contrasting strengths and weaknesses, navies historically used these two systems in tandem rather than as competitors. ELF as the bell ringer. ELF was utilized as a one-way pager. If command authorities needed to urgently contact a deeply submerged ballistic missile submarine, they would broadcast a short, pre-arranged 3-letter code over ELF. VLF as the messenger. Once the submarine received the ELF page, the commander would know to bring the vessel closer to the surface. The submarine would then deploy its trailing wire antenna to receive the actual detailed VLF broadcast or raise a mast for high-speed satellite communications. VLF remains a highly active, heavily relied upon system for naval forces worldwide today, functioning as the backbone for strategic submarine broadcasts. Conversely, many ELF systems like those in the US have been decommissioned due to their massive operational costs, immense power requirements, and improvements in other stealth communication technologies, though a few nations still maintain them.